Okay, friends, here example number 1.14 from the exercise. You are given a figure, and this figure indicate that the upper layer is charged with positive charge and lower layer is a negative charge. So here you are given three particles. So these three particles you have to identify that which kind of charge is placed on these three particles. Okay, so friends, you can see here these two particles are attracted towards the positive charge, and the third one is attracted towards the negative charge. So you know that unlike charges can attract each other. So you can understand that this is a positive charge, so obviously the negative charge must be attracted toward the positive charge. So these both charges are negative charge, and this is a positive charge. Okay, so here in this question you have to identify only the type of charges. Okay, this is general knowledge you have to use here. In 1.15 you are given electric field, and that is equal to 3 into 10 raised to 3 Newton per Coulomb. But here specific I cap is given. That means the direction of electric field is toward the x-axis, and a square is here. See, this is x-axis, this is y, this is z. So here this is yz plane, this is yz plane. So the direction of area of this yz plane must be toward the x-axis, and this is given 10 centimeter over here. Okay, so friends, you have to find out flux. What will be the flux with respect to this area? So your length is equal to 10 centimeter, that means 10 into 10 raised to minus 2 meter, and it means 10 raised to minus 1 meter. So this is your L, and due to this L your area is equal to L square because it is a square. So 10 raised to minus 1 square, so it is 10 raised to minus 2 meter square. So this is your area, and it is in vector form. You can write down in this way. So now if you want to find out flux, so by using electric field and area, you can write down this formula. E dot A, that means 3 into 10 raised to 3 I dot 10 raised to minus 2 I. I dot I is equal to 1. 3 into 3 minus 2 is 1. So 3 into 10, and that means 30 Newton meter square per coulomb. This is your answer. Okay? Now, guys, see. This is the part A for 1.15, and in part B, beta, you have to read out your questions with when you are watching the video, you should keep your textbook in front of you. By after reading the question, you have to watch the video. Here one more question is that in 1.15 the square is making angle of 60 degree with x-axis, and if angle is 60 degree, so again you have to find out flux, again you have to apply the same formula. So it is when you are removing this dot, EA cos theta. 4th chapter, 11th standard. So now apply. Cos 60. So 3 into 10 into 1/2. It is 1.5 into 10. So 15 Newton meter square per coulomb. So friends, here 1.15 is there. It is done. Now 1.16. You are said that suppose instead of this square, if a cube is placed over here, then what will happen? Can you get the flux or not? So if here cube is placed, cube, that means it has 6 sides. So when electric field line is passing from one side, then it will goes from another side. So there isn't any single plane over there. So there is no any kind of flux is there. So 1.16 flux is equal to 0. Now 1.17. So in 1.17, when we have a cube of length 20 centimeter, okay, we have a box, and flux is given 8 into 10 raised to 3 Newton per meter square. So you have to find out what is the electric charge inside the flux, inside the box. So you are given a closed box. So Gauss law says, if any electric charge is covered with any kind of a cube or sphere or spherical cell or cuboid, any closed body which is covered, which covers the charge, then the flux must be Q upon epsilon 0. But here you have to find out only Q. I can write down in this way, and if epsilon will go there, phi epsilon 0. Here phi is given 8 into 10 raised to 3 Newton meter square per coulomb, and epsilon 0 8.85 into 10 raised to minus 12. If you are going to apply this value, you can find out charge Q. And second question, in this case, you are asked that if the flux is 0, this is A. B said if flux is 0, that means Q is equal to 0. Because if charge is not covered by any body, then flux cannot be created. There must be a charge if you want to create flux. So if flux is 0, then charge is 0. If charge is 0, then flux is 0. So now 1.18. See, in 1.18, it is important. This one is also must be done by you. So here you are given a square. A square of length 10 centimeter. This is a square. Square is given. And from the center, 5 centimeter high, a charge 10 microcoulomb charge is placed over here. Q is equal to 10 microcoulomb charge is there. So you have to find out how much flux can be created from this square. So friends, we have to consider a cube whose base is this square. See, I am considering a cuboid. I am considering a cube, and this is 10 centimeter. That means 10 centimeter everywhere. So this is the center, and here 5 semi. That means your Q is on the center. Q is equal to 10 microcoulomb. That is in the center of this cube. Now the charge center of the Gaussian plane Gaussian cube. So flux is equal to Q upon epsilon G. But you can see this cube has 6 sides, 6 surfaces, 1, 2, 3, 4, 6. But you have to find out for only one. So this flux is for whole cube. You want to find out only for one. So it is only like this. So Q is equal to 10 into 10 raised to minus 6. This is 6 into 8.85 into 10 raised to minus 12. So beta, this is your answer. Please try yourself. And you have to write down all the sums in your notebook. And please write down, calculate yourself, try again and again. I must be there at your home, anytime to check out your notebooks. So please make notebooks for all subjects, okay? And stay home and be safe at your home. Thank you very much.